Welcome to episode 2 of Talking Pavements. My name's Trenton Clark, and with me is David Lee, and we're with the Virginia Asphalt Association. In this episode, we're going to be talking about asphalt, the ultimate green solution. And as we go through this webcast, you'll see why we say it is the ultimate green solution. Before we get into it, let us tell you a little bit about Virginia Asphalt Association. We were formed nearly 70 years ago in 1952. We're a technical trade association for Virginia's paving industry. And what we do is we spend our time helping educate, train, increase the knowledge base in this industry. Our members, we have nearly 120. There's about 120 here in Virginia and across the U.S. It ranges from the large asphalt producers to the small asphalt producers, to the companies that lay the asphalt, to the companies that put line markings on your roads. It also includes some companies that supply asphalt to companies. It supplies aggregate. It could be supplying equipment. So we got a wide range of membership as part of VAA today. So it's a great diversity, a lot of knowledge coming together under one umbrella association. So that's a little bit about us. Today's topics on asphalt, the ultimate green solution, is first we're going to dispel some myths, some fiction that's out there. Yeah.
Yep, there's plenty of fiction to go around. That's for
There's
sure.
a lot of fiction. We're also going to talk about actually the facts, what studies have been done, how there's a lot of information out there. And then most importantly, if you have questions, just use that Q&A portion in Zoom, type in your questions, and at the end of the webcast, we'll take a few minutes and answer as many as we can.
Yep.
So first, give them a little background on what is asphalt.
Yeah, let's just talk briefly about asphalt and just the basics of asphalt. Keep in mind that asphalt, it's a natural substance, and it has a lot of varying physical properties. First of all, it's both adhesive and cohesive. If you think about it, the asphalt, the liquid asphalt, is the glue of an asphalt pavement. It holds it together. That overall pavement structure has to remain flexible. It needs to be able to bend under loading. And so it is a both adhesive and cohesive product. So it's sticky and elastic. It's non-soluble. And we'll get into that a little bit later why that's important. But it's important for many reasons. Both from a performance perspective, we want obviously the asphalt, the liquid asphalt, to stay on the pavement structure. We don't want the water that's coming from a rainstorm to wash that asphalt away, because then you no longer have that structural rigidity of your pavement. So it is non-soluble. And then it's highly viscous. The material has to obviously be able to be heated, and then it becomes viscous when it's heated, and it will be compactable. It can be placed. And then when it gets back to air temperature, it's firm. It's a rigid pavement structure that can handle all the loading that we want to put on it.
Right. So it does a bit of everything.
It does. Absolutely. So the liquid asphalt itself, well, liquid asphalt's been around as long as dinosaurs.
It was dinosaurs.
It was dinosaur. Exactly right. So you can go to the pitch lakes in the island of Trinidad, and there's some liquid bitumen at that, at that location. And then the La Brea tar pits in California. You can actually go to California and go to the La Brea tar pits. I wouldn't go out sticking my hand in it or anything like that, but they are there even today. But all of our asphalts today come from crude oil and the refining process from crude oil, just like your gasolines for your cars, diesel fuel, kerosene. It's a refining process coming from crude oil that takes those, and it actually, in the refining process, it pulls them off. The bottom of that refining process is our liquid asphalts.
Yep. So it's part of a bigger overall refining process, and we use the asphalt as part of it to build our roads today. So really, over the many, many years I've been in this industry, I've heard really 3 big misconceptions, misinformation. It's really been more so in the last 10 to 15 years. Either dealing with the fumes or basically the smell.
The smell. Yeah, the smell is a big thing. Everybody's driving down the road and they go through a paving operation. They say, man, that's a strong smell.
So we'll talk about that. We'll also talk about, does it pollute? And a lot of the concerns come around with recycled or recycled asphalt pavement. Does When it's ground up and stockpiled, or it's put down on a driveway, or put down on a parking lot, does it pollute the groundwater?
We'll talk about that.
And then the last thing, well, asphalt, because it's black, it's what's causing all the cities to heat up, the urban heat island effect, and we'll talk about that. Well, let's first just really address the paving fume. So whether you are near an asphalt plant, you drive by one, you drive through a paving operation, you may smell a dump truck that has asphalt on it. Fumes are coming, it's just smell. So think of it like I do as a Krispy Kreme donut.
Right.
You know, you smell the Krispy Kreme, smells good. To some of us, asphalt smells good.
Right.
But there was concern is, does the fumes cause cancer? Yeah. So there was a large study started about 10 years ago that looked into that, the fumes from asphalt.
Particularly focused on the workers, because they're
Yeah.
the ones that are exposed to it the most.
Well, the workers are the most valuable asset a company has. Without workers, you don't have a company.
Exactly.
So they're very concerned to make sure that their workers were protected. So they went through this international study, went through, looked at all the known data, gathered it all together. There's been years and years and years of research. And at the end of the day, they determined there's no direct link to cancer from asphalt paving fumes. So what you smell or what those workers are exposed to at the asphalt plant or right behind the paver, they found no direct link. What they did do is they classified it as 2B. 2B means possible carcinogen. You say, well, it says possible. Again, no direct link. And remember, aloe vera is also 2B. Pickled vegetables are 2B. And unfortunately, red meat is there too. So again, while it was classified there out of the abundance of caution, there's no data to support it. So what does that mean? Don't worry about the smell of the asphalt. You may not care for it. There's lots of places we have asphalt plants that you probably don't even know it exists. But again, the smell of the asphalt is not a concern. So when we hear it, just wanted to dispel that myth.
Right.
The next myth is pollution. That asphalt runs into the groundwater and it pollutes the groundwater. This is a very regulated industry. Just like over on the fume side, when we're doing a lot of stuff at the plant, we'll talk about that in a few minutes. We also do lots of stuff around the plant to make sure that there's no groundwater pollution. We have, as David said, it's inert, so it doesn't dissolve in water. The asphalt plants have to have stormwater prevention control plans. So anything that gets washed off has to be captured. So we have done many things, and a lot of the regulations over the last 20 to 30 years is to make these sites very clean. And even if you see stockpiles of wrap, you may see them along a road, a farmer may use them in the fields, or that maybe in a driveway or in a large parking lot. A lot of that, we've done, again, studies to make sure what may be seen is stuff that's on the pavement, but where do they come from? The drippings of cars,
Right.
The drippings of trucks,
Right.
Other things. And we'll talk about ways that that can be mitigated today with specialty pavements. The asphalt itself, you don't have to worry about that pollution. Lastly, you hear a lot of this
Urban heat island.
urban heat island. Urban heat island, basically, if you think about it, urban, so we're talking about our cities, heat, we're talking hot. An island, if you think of a big map and you think of your city is surrounded by green, they consider that an island. So be crazy to say no, asphalt does not get hot. If you remember basic science from high school, dark colors absorb heat, light colors reflect heat. So if you think about it, it's a darker material. It will absorb the heat, just as you see in these thermal images. You can
get hot.
It gets hot. Don't walk across it barefoot, but it absorbs the heat.
Right.
The lighter colored surfaces, yes, the surface of it will be less, still warm, but it's still less. But what it does is it reflects it. Right. So whereas asphalt is absorbing it and it's going into the ground, the lighter reflected, it goes into the air. And what's been interesting is some of these studies, whether it's the this picture from UC Davis, it shows that reflected light, that reflected heat actually warming up your building. So the buildings are hotter. They have to work harder in air conditioning to cool them off. So if you're glass, if you're brick, if whatever that exterior, the building is getting hotter. Also, Arizona State looked at the LA's cool pavements where they did a lot of light colored surfaces. And what happens? It feels hotter to the pedestrians because it's right above where that heat is reflecting back up onto the folks. So
the air around them itself just starts to heat up because it's all reflected, as opposed to the asphalt pavement that would absorb some of that heat.
And at the end, and this should come as no surprise, there's a recent study that was released in Europe where they looked at ground monitoring gauges, temperatures from monitoring stations. They looked at satellite data. Satellites overestimated the impacts of temperature increase compared to what you had with monitoring stations.
Right.
What it came down to is what all of us know. When it's a hot outside, where you go looking?
You go under a tree.
You go under
a canopy, something.
You need a canopy. You need to go somewhere that is cool. Underneath the trees, it's cool.
Mm-hmm.
And they found by having canopies in these urban areas, these trees, to absorb the heat, cools off the city. So it really comes down to having that right trees in your neighborhoods to keep your cities and your neighborhoods cool.
Right. Absolutely. So let's talk about how is asphalt green? We talked about a number of things and technologies associated with asphalt this morning and what asphalt's made of, but how is asphalt itself green? Let's talk about the asphalt plant and the mixed technologies themselves. If you think about it, asphalt plants have been around for a long, long time.
Yeah.
And many years ago, a lot of the plants did use a lot more fossil fuels for their heating. They used diesel fuel. They burned used oils that were used to heat those. But now today, a large percentage, and if not most of our plants use natural gas.
Right, because it's available.
Yep, and it's clean burning.
It's very clean burning.
Yep, and it's more efficient typically.
Yep.
So you get a lot more BTUs out of natural gas than you do, say, out of diesel fuels. So it is a much better process, not only for the actual production of the asphalt itself, but it's a more environmentally.
Right. And with these plant technologies, we're optimizing the burners. So more the heat is generated to go into it to reduce the emissions. So they are optimized. They're tuned just like you tune a guitar.
Right.
They tune the burners to be as efficient as possible. We store aggregates and wrap underneath a lot of canopies, a lot of Quonset huts. Why?
It keeps them dry.
And if you don't have to get it dry, or if it's already dry, then you can use less temperature, less heat to dry out the aggregate, because we don't want to use wet aggregate.
Right. But we also use a lot of mixed technologies as well, such as warm mix asphalt. There's a lot of additives and mechanical processes such as foaming that you can use in an asphalt plant, which allows you to bring those production temperatures down. So you may, without those technologies, be running your mixes in the 325 range. And with a warm mix technology, you can bring it down much lower than that, into the 250 to 275 range. So therefore, you're burning less fuel.
Yeah, and at the end of the day, not only are we trying to be good environmental stewards, but it's also about cost and controlling costs. So with natural gas, they have a reliable, less expensive, cleaner burning type fuel. The burners are more efficient, more optimized. They're doing more and more to keep that aggregate dry so they don't have to heat up. All these things just reduce emissions.
Exactly.
We also use a lot of recycled products into our asphalt. Recycled asphalt pavement's the #1 recycled material in the world, more so than paper, more so than aluminum cans, more so than plastic, because we can mill those pavements up, process them, and put them in the new mixes. We also use a lot of shingles. Depending on where you're at in the country, there's more or less. Here in Virginia, less is used because we do have a lot of wrap, but there's different places, but we have to use them responsibly because it is made out, the shingles on your roof are very hard binding.
Right.
So you have to incorporate that with other materials, softer binders, different additives. So the mix isn't so brittle that it cracks. And then we're using lots and lots of tires. Depending on where you're at in the country, there's mandates. Here in Virginia, we've done projects dating back to the early 90s, but it's only been in the last decade or so that we've been using ground tire rubber or crumb rubber into these mixes. So again, because one, we're keeping them out of the landfills, but two, just as importantly, it works really, really well.
Yeah, it improves the performance of our mixes, so why not use it?
Yeah. We have used glass in the past. We had mixed performance with glass, so you don't see a lot of glass fault being done unless it's on a small private job. But like all things, more research is going on. We got bio-based binders. So whether it's coming from some other organic materials that are making asphalt binders. So lots of things are going on to recycle materials. A couple of years ago, every year, National Asphalt Pavement Association works with Federal Highway to collect data on how much recycle is being used, how much warm mix technology is being used. And here's just a summary of some of the data from 2019. You can see 28% wrap, pretty much average across the board. What you need to keep in mind is the amount of wrap that we use in an urban area is completely different than a rural area, because we got much more wrap because we have to mill almost all of our projects because you got to tie into your
Curb and gutter,
driveways, intersecting roads.
Mm-hmm.
The great thing about that is that the plants that are in most of these areas can run 40 to some of them now up to 60% recycle when processed properly. The big limitation right now is just specifications.
Right.
Most clients, whether it's VDOT, Federal Highway, localities, have a limit on how much we can put into it. For our private customers, a lot of the members will run, if their plants can handle it, 40-45% wrap, because it is an effective material. It's a well-performing material, and it's really beneficial to utilize that versus bringing in trucks with more aggregate, bringing in trucks with more binder. Keeping trucks off the road keeps carbon out of the air.
That's exactly right. So let's talk a little bit about that porous asphalt. You were talking about it earlier when we were talking about technologies that are used to basically control stormwater. And porous asphalt's one of those. So we can take now a pavement that's designed to actually allow the water to penetrate through it. Most of our pavements are designed to be pretty much impermeable, but so they allow the water to basically wash off and go into a stormwater management pond or into a stream or to the rivers. But today's technology with these asphalts allows us to allow that water to penetrate through the porous asphalt itself into a drainage basin that can control that water and allow it to penetrate into the ground. That provides lots of benefits. It's not really a new technology.
No, not at all.
Been doing it for many, many years in various facets. However, we've modernized our technologies. We talk about some of the polymers that we use in our asphalts. That's allowed us to produce a high performing porous asphalt pavement. And it allows that water to penetrate into the pavement structure and no longer actually wash off of the road and have to go into a stormwater management pond. You can think about, maybe in your own subdivision, you've got a stormwater management pond that's huge. It has to be able to control a lot of water and then allow that water to sit in a pond. They have to be maintained. They're very difficult. They take up a lot of land.
Right.
So if you're in an urban area, it can be very difficult to have the proper stormwater management ponds because it just takes up so much land. Whereas now with a porous pavement, you can put that reservoir underneath that pavement structure and allow that water to penetrate through the pavement down into that reservoir, and then it'll penetrate into the ground, and it actually literally cleans through that process because it now goes into the soils that are below, and that biotechnology that's there,
Those organisms
and the enzymes that are in the soils, they actually eat all that. And really what you're trying to get is the fuel oils off of the cars, the drippings, the trucks that drip, particularly in parking lots, if you think about it. Instead of washing off now and going into our streams and our rivers, it actually penetrates that pavement structure.
Right. So much has changed with not only the industry, but within asphalt. But if you go back far enough, a lot of the stuff wasn't a concern. Right. Our older roads, just had ditches. Or it had nothing there. A lot of our, anything we build today has to have some sort of stormwater management process with it. Right. And with stormwater going into these porous pavements, again, it allows us to capitalize on the technology. And as David said, in an urban area, think of how much an acre of land costs.
Right.
If we can store all the water underneath, have it penetrate that way, the savings overall, plus now you have that beneficial piece of property for something else.
Right.
What we'd like to just show you real quickly is how the porous pavement work. This is just a video that I captured a few years ago. As you can see, it's just a 16 or 18 ounce cup of water being poured onto the surface. And in about 30 seconds time, the water disappears. So it's not running off anywhere. It's going into the structure. And while we don't normally get a rainstorm that drops 18 ounces in a concentrated spot in about 5 seconds,
Right.
if we do, we have many bigger
Much
issues.
bigger issues.
But that's how porous pavement works. Now, the one thing we'll caution you is we get phone calls quite often. I want a porous pavement driveway.
Right.
Where can I get porous asphalt? We say, you know, that's wonderful that you're thinking of it, but you have to think of the entire system. It's more than just the asphalt. You have to have the stone reservoir underneath of it. It has to be constructed properly. So the water does the same thing on your driveway.
Right.
It goes on the top, straight down, and then it sits in that stone reservoir, and then it slowly infiltrates the soil.
Right.
If it doesn't do that, all it's doing is draining on the top, running out on the bottom, and it's not doing us any good. So recycling is huge. We've done some of this technology since the 60s. We had to get into recycling, honestly, with the oil embargo of the early 70s. You remember it? I don't. I'm nowhere near as old as you.
Unfortunately, I do.
Yeah,
You're
so,
not that far behind me.
but we had to start milling.
Right.
Why? Because asphalt itself is just rock and asphalt.
Yep.
And we were able to utilize that asphalt that was on that existing pavement in the new pavements.
Right.
Well, as time has gone on, yes, we've done full depth reclamation, one shape or form, but all these other things have really taken off in the last 20 years, and some of these in the last 10 years.
Exactly right. Yeah. Some of the equipment technology has improved a lot. So we have cold in place recycling, where you have large machines that can actually mill up the pavement and add additives back to it and some more liquid asphalt and literally just place it right back down behind the machinery and compact it in place. So it never leaves the site. So as we talked about earlier, you don't have all that trucking cost, but you don't have all those environmental concerns with the trucks hauling back and forth. It's a safer operation typically because of that. Also, we have cold plant recycling, where you can actually mill up that pavement just like we do on a normal process and take it to a cold central plant. They process that material and can bring it back out and pave it on a roadway just like you would with a regular hot mix asphalt.
Yeah, and all these technology, full depth reclamation, think of a road that's gone, it's given up its life. It needs to be reconstructed, but why dig it all up and haul it away? You got it in place. The full depth reclamation, some of this equipment has multi-purposes, but think of it just going through there with a giant tiller.
Yep.
Where you're working it all up, you're adding additives and coming out the back, you've got a pavement foundation. We've used these on lots of different projects. We've done research on them. We've actually put them in the field. We've got I-81 south of Stanton that's 10 years old, performed great. Down at the National Center for Asphalt Technology, we've put in multiple sites. They performed exceptionally well. I-64, from here in the Richmond area down toward Virginia Beach, the Hampton area, there's a couple sections there that together they make up the largest recycling projects in the world to our knowledge, because it's so much of reusing crushed concrete and the FDR layer. We're actually using all the asphalt to go back into the cold central plant mix. So we have these technologies, not to mention the wrap that's in our new asphalt that's going down. All in all, what are we doing? We're reducing demand for virgin materials. We're also reducing the need for the amount of trucking to bring it in, which all in all cleans up and reduces the carbon footprint. So a few things, and then we'll take your questions. Asphalt's green, pavement It's green. The technology is green. We're using asphalt pavements today to capture stormwater, to treat stormwater. The industry itself is very regulated. We have lots of permits that we have to adhere to. The plants get inspected. So we're making sure that the emissions that are coming are as low as possible to continue to keep the permits. The companies are the people in your neighborhood. They're the people that you may go to the church with, or people that you see in the grocery store. They have a commitment to be good environmental stewards.
Absolutely.
Because they're there too.
Right. It's their community as well.
Yep. And we got lots of research underway to see what else can be incorporated. We mentioned plastic earlier. Lots of research is underway to see how can we effectively use the different plastics that are produced that are now, they're starting to pile up.
Starting to pile up, yes. We got to find ways to recycle those. And there's a lot of research going on to this day to try to answer that question.
And if it proves out that it works, guess what? You'll see plastics in our asphalt mixes. So if you have any questions, we have stuff on our website. Just go to the VAA website and click on it, and you can search for recycling. But with that, if you've got any questions, we'd love to answer them. We've got time, just put it in the Q&A. But if you have questions afterwards, maybe you're watching this video on YouTube later, there's our contact information. Just shoot us an email and we'll be happy to respond. Thanks a lot.
Thank you very much.